example that to review is find the distance and midpoint between 2 points. And the 2 points here are 8, 4, and 8, -6. Okay, so these are 2 points. So first, let's use the distance formula. The distance formula is given by the square root of x2 minus x1 squared plus y2 minus y1 squared, where x1 and y1 would be 1 point and x2 and y2 would be the other point. Now it doesn't matter which point you pick to be point 1 or point 2 as long as you follow the order on the formula. Okay, so it doesn't matter whether you're going forwards or backwards, the distance is going to be the same. All right, so let's go ahead and substitute. I picked 8, 4 to be my point 1, so 8 is x1, 4 is y1. I picked this second point to be my point, so x2 is 8 and y2 is -6. So we do the substitution, we plug them in, and then we go ahead and simplify. 8 minus 8 is going to give me 0. -6 minus 4 is going to give me a -10. Okay, 0 squared is 0, and -10 squared is 100. So 0 plus 100 is the square root of 100. So we want to simplify that, and the square root of 100 is 10. Okay, we do get a plus or minus, but again, distance cannot be measured negatively, so it's always positive. So this is an example of using the distance formula. Now let's look at the midpoint formula. So to get the midpoint of 2 points is given by x1 plus x2 divided by 2 and y2 plus y1 divided by 2. Again, where x1 and y1 is your point 1 and x2 and y2 is your point 2. So let's do the same. Let's go ahead and substitute. So we have here a plus 8 divided by 2, -6 plus 4 divided by 2. Again, the a plus 8 divided by 2 is going to give me the x value. The -6 plus 4 divided by 2 is going to give me the y value. So when I do that, a plus 8 is 16 over 2. -6 plus 4 is going to give me a -2 over 2. Let's go ahead and do that division. 16 divided by 2 is 8, and -2 divided by 2 is -1. Okay, so again, this is review, but please, if you guys have any questions, raise your hand, put it on the chat, and we can go over anything that you still is not clear. Okay, thank you. All right, so let's look at this other example. Write the standard form of the equation of the circle with the given characteristics. We have a center at -4, 2 and a radius of 2. So in order for us to do this, we need to know the standard form of a circle. Okay, so the standard form of a circle is given by x minus h squared plus y minus k squared is equal to r squared, where h and k is my center and r refers to the radius. Okay, so all this problem requires is just to plug in the information. So they gave us the center, which is -4, 2, and they gave me the radius, which is 2. So once I plug these in, let's go ahead and simplify. A negative with a negative is going to give me a positive, so we have x plus 4 squared. And the positive with a negative is going to give me a negative, so we have 1 minus 2 squared. And then the radius is 2, so 2 squared is 4. So that is my answer. This is the equation, the standard form of equation of a circle with these given characteristics: a center at -4, 2, and a radius of 2. So let's look at another example, because these are fun, right? I hope. Find the center and radius of the circle. So on this one, they're giving us the equation in standard form, and they want us to find the center and radius. So hopefully we can see that if we understand the equation of the circle. So the standard form of a circle again is x minus h squared plus y minus k squared is equal to r squared, where h and k is my center. So in this problem, I know that my h refers to that value 1, that k refers to the 2, and the r squared refers to my 25, right? So here, to get my center, for this 1 to be a negative, I know that my 1 has to be a positive, yes? And for my k, for this to be positive, I know my 2 has to be negative. See, so you see it here. And then we can also take um, the square root of 25, because the opposite of a square is a square root, so we can get our radius. So having this information, we can get our values, right? So here, our center, hk, is going to be a positive 1 and a negative 2. And my radius, again, by taking the square root of 25, or solving for r, we have r is equal to 5. Okay, all right. So let's sketch this graph. Um, so here we start with our center and our radius. So let's go ahead and plot first our center. Our center means it's the center dot or point of our circle. Okay, so when we do this, here's our center. We have 1 unit to the right, 2 units down. Our radius is 5, so that means that all of the points from this center are of distance 5. Okay, so again, we can put a point to the right, a point up, a point down from my center, and a point to the left. So all these points are 5 units away from my center. So to graph this, again, we try to do a smooth circle, or combining all these 4 dots that are around our center, and voila, this is the graph of our circle. Okay. All right. Let's look at this next example. Find any intercepts and test for symmetry with respect to both axis and the origin. So hopefully by now we know that to find intercepts, what that means is where the graph is crossing either the x-axis or the y-axis. So to find the x-intercepts, we set y equal to 0. To find the y-intercepts, we'll set x equal to 0. So let's go ahead and do that first. Let's find our x-intercepts. And again, to find our x-intercept, we're going to let y equal to 0, and we're going to solve for x. So let's go ahead and substitute y for 0. So we have 0 is equal to negative 4x plus 1. And let's go ahead and solve for x. So the first thing I'll do is I'll subtract 1 on both sides. And this is going to give me 0 minus 1 is negative 1. 1 minus 1 is 0, so we're left with just a minus 4x on the right side. So the next thing I need to do is I need to divide both sides by a negative 4. And when I do that, again, a negative 1 divided by a negative 4 is going to give me a positive 1 over 4. And a negative 4 divided by a negative 4 is just 1, leaving me with the x. So the equation of the x-intercept is x equals 1/4, or if the computer asks you what is the ordered pair of the x-intercept, well, the x value is 1/4, the y value is 0. Okay, so let's go ahead and do the y-intercept. Let's let x equal 0, and let's solve for y. So everywhere I see x, I'm going to plug in a 0. So we have y equals negative 4 times 0 plus 1. So negative 4 times 0, that's 0. And 0 plus 1 is 1. So the equation of the y-intercept is y equals 1 as an ordered pair. This is telling me that x is equal to 0 when x is equal to 0, y is equal to 1. And these are our intercepts. Okay? All right. Now let's look up to test for symmetry. So to test for symmetry, okay, we know that this is a line that has no symmetry, but we can test it because this is the graph of it, but we can test it, okay? So to test for symmetry, we have several guidelines, okay? So the first one, let's do the first one, to test algebraically. To find if a graph has x-axis symmetry, excuse me, given x and y, if we replace the y value with a negative and we still get the same equation, then it has x-axis symmetry. If we have y-axis symmetry, if we replace the x value with a negative symbol and we still have the same equation, then it has y-axis symmetry. And for origin symmetry, if we change both of the signs and we still get the same equation or a true statement, it has an origin symmetry. So let's go ahead and go through these. Let's check for the x-axis symmetry on this equation. Y is equal to minus 4x plus 1. So we're going to replace y with a negative y and solve for y. Okay, so when we do this, we have negative y is equal to negative 4x plus 1. And we solve for y. So to solve for y, we need to multiply by a negative 1 on both sides. And when we do that, or we can divide, doesn't matter. We can divide by negative 1 on both sides. We're going to get this. Y is equal to a negative 4x divided by a negative 1 plus 1 divided by a negative 1. And when we simplify, we get y is equal to 4x minus 1. And if we see that these are not the same statements. The original one was y equals negative 4x plus 1, and we end up with different signs. We have a positive 4x and a negative 1. So hence, since these two are not the same, this has no x-axis symmetry. Now let's check for the y-axis symmetry. We're going to do the same, except we're going to replace the x with a negative value, right? Um, so when we do this, we have negative 4 times a negative x plus 1. When we simplify that, we're going to get a positive y is equal to positive 4x plus 1. And if we see, these two are not the same equations. We had a negative 4x on the beginning, and we have now a positive 4x. Now, our 1 is still positive, but it's not the same because of that negative 4x and positive 4x. So hence, this also has no y-axis symmetry. So let's check for the origin symmetry algebraically. We're going to change the sign on both for the y and for the x. So let's go ahead and do that. We're going to get negative y equals negative 4 times a negative x plus 1. We'll simplify and solve for y. Okay, so we have negative 4 times a negative x. That's a positive 4x plus 1. Let's divide by a negative 1 on both sides. Okay, and when we do that, we have y is equal to negative 4x minus 1. And as you see on this particular one as well, we have the same negative 4x, the sign, but our plus 1 became a minus 1. Since these two are not the same, they're not equal, therefore this equation has no origin symmetry. So again, this linear equations do not have either x-axis, y-axis, or origin symmetry. But these are the cases or rules that you have to follow algebraically in order to find out what type of symmetry an equation has. Okay, all right. So let's look at another topic. Determine whether the equation represents y as a function of x. Okay, so if we were to graph these, this will make our life really easy, because in order to find out if a function is a graph if an equation is a function, we need to find that every x value only corresponds to one y value. Okay, and again, if we have the graphs, we can perform this statement by doing a vertical line test, right? The vertical line test, or imaginary vertical line test, will determine that every x value corresponds to every y value. So in this first case, we have a linear equation, right? So if we had an imaginary vertical line and we traverse it through our graph, we will see that our imaginary vertical line will only cross our graph once. So that means that every x value only corresponds to one y value. So our first equation, y equals x plus 4, does represent a function. Okay, now let's look at our second equation. Okay, by now we should know that this equation is a quadratic equation and is represented by a parabola shape, right? But again, having the graph, I can perform my vertical line test. Okay, that I run an imaginary vertical line through my graph, and I'll see that my imaginary vertical line will only cross my graph only once. So hence, this equation is also a function. Okay, let's graph our square root function here. So this square root function is in this shape. Again, if I perform my imaginary vertical line to test every x value corresponds to only one value, this is true. It passes. My vertical line test passed. So hence, this is also an equation. Oh, we just dealt with this type of equation. This last example, if we were to graph it, has a radius of 2. It's a circle, right? So in this one, if we perform our vertical line test, we will see that it fails, right? We're going to hit 2 places, right? So um, hence, this equation is not a function because it fails our vertical line test. Not every x value corresponds to one y value. So just as an example, if I were to choose 1 here, okay, 1 sometimes is represented by let's say a 1.9, and 1 also is represented by a negative 1.9, and have 2 values for one given x. So hence, it fails. My every x value has to have only one y value. All right. So let's look at these. Determine whether the equations represent y as a function of x. Okay, so let's more of the same. Let's go ahead and graph our first equation here. We see that this is a cube function, our cube equation. And if we do again our vertical line test, we'll see that our imaginary vertical line will only cross our graph once. Hence, every x value only corresponds to one y value. So yes, this equation also is represented by a function. Uh-oh, this is a square equation, but the square now is on the y. So basically, the graph of this, its major axis, or we were to solve for y, um, we have this, right? We have um, that if we had a value, okay, for x, we'll see that the 0 will give us 2 solutions. When I put x for 0, 0 plus 4 is the square root of 4, which is 2, and 0 plus 4, the square root of 4 is 2, but also the negative, so it's 2. But again, we can see that this is like a parabola on its side. Okay, if we were to graph this, we have a parabola on its side, and it would do the vertical line test. It's going to cross these 2 places at 2 and negative 2. Okay. All right. Oh, and here it goes. So this is my parabola that is on its side. Our major axis is now the y-axis since the y has the square. And you'll see that it fails my vertical line test. Okay. All right. Let's look at this graph. Use the graph of f of x, which is the square root of x, to write an equation for the function represented by the graph. Okay. So as you can see, this looks like my square root of x, but it's not at the origin, right? So let's write the parent square root of x. So this is the parent function, and I see that it's very similar to this, but it's in a different location. It got some transformations, or it got shifted. So the first transformation that I'd see, this from my parent function, my graph got shifted to the left 2 units. So to represent that shift is given by this equation, the square root of x plus 2. I'm adding 2 to the x, which is going to make my graph shift 2 units to the left. Now I know what you're thinking. It moved to the left, but I have a plus 2. So what I tell my students is think of the x-intercept. If I wanted to find the x-intercept, I would set this equal to 0, right? So to get rid of the square root, I square both sides. So I would have 0 is equal to x plus 2. And to solve for x, I'm going to subtract 2 on both sides. So x is equal to negative 2. So this is the reason why this graph moves to the left. Even though there's a plus 2, if I was thinking of its intercept, I really have to move that 2 to the other side. And by moving it to the other side, it makes it negative. Okay? So this is the first part. So, but I still not the same graph that I have given. I also see that this graph got shifted 8 units down. So that is affecting my y variable. So to represent that in the equation, it's outside the square root because I'm not doing anything with the x. Again, the x will control my horizontal shift. If I do something to x, my x is going to move it left or right. But if I affect my y, again, that's going to make it move up or down. And since the negative 8 is already on the correct side, so this is telling me that y is equal to negative 8, this is going to make my graph shift 8 units down. So the answer for this graph that they're representing here is based on my parent function square root of x, but it got shifted 2 units to the left and 8 units down. Okay, let's look at another example. All right, how about this one? This one's a little tricky. It looks like my square root and it's telling me that it's from the square root, but it's a little bit odd. But let's go through its transformations. So again, let's write my parent. My parent has this initial start at 0, and it's going to forever to the right. So the first thing that I see, okay, that it has a reflection on the x-axis. So to show that reflection, I'm going to multiply by a negative value to my square root. And again, that's going to create my graph get reflected on the x-axis. But I also noticed another thing. It's also reflected on the y-axis. And to show that algebraically, okay, you see that it's pointing the opposite direction. It's not pointing forward. Okay, what that means is that I want to look at only the x values that are on that side. So to do this transformation, I'm going to write negative square root of x times a negative x, or negative 1 times x, yes? So this is going to give me that flip to the other side, that y reflection. All right, so we're almost there. So we also see that it has another transformations. It got shifted to the right 2 units. Okay, so we know how to represent that. So since it's shifting to the right, we're going to subtract 2 units from the x again because we want to move it to the other side. And then it also got shifted 5 units down. So that it's going to be outside the radical. Don't put the negative 5 inside because we want to affect only the y value. So we would have minus 5. So we are done. This graph is represented by f of is equal to negative square root of negative x minus 2 minus 5. Okay? All right. Please ask any questions. Let's look at another example. Write equations of the lines through the given points parallel and perpendicular to the given line. Awesome. So the first thing we need to know that if we're wanting to write equations that are parallel and perpendicular, these are determined by its slope. Parallel lines have the same slope, and what I like to say, perpendicular lines have kind of opposite slopes. Okay, and we'll talk a little bit about that. Um, so the first thing that I need to know is the slope. Now they gave me the equation in general form, right? I like to say general form, which is 8x minus 2y is equal to 3. But if I really wanted to find out what the slope of this equation is, what I would do is convert it into slope-intercept form. And I do that by solving for y. And by me doing so, it will let me know what the slope is, which is crucial because if I want the parallel line, the slopes have to be the same, right? So let's go ahead and do that first. Let's go ahead and apply, solve for y to get it in slope intercept form. And when I do that, I get this. Y is equal to 4x minus 3 half. Now this negative 3 half, again, it's in slope intercept form. This is the y-intercept, but I'm not interested in that. All I'm interested in its slope. So the slope of this given equation is 4. So the slope is represented by m. M equals 4. So now they're telling me that they want me to they find the equation that goes through this point. Now there's two ways of doing it. I can use my slope-intercept form, plug in these values, and solve for my y-intercept. Or what I can do is I can do the point slope formula, and also will give me the same result. So let's see. Let's go ahead and practice our point slope formula. Okay, so we have for two lines to be parallel, they have to have the same slope. And since they're telling me to go through this particular point, 8, 1, that's the reason why I wanted to use a point slope formula, because the point slope formula says that given a point, I can come up with the equation where x1 and y1 is the point that I want the equation to go through. So let's go ahead and do the substitution. So let's substitute what we know. So we know the y1, which is 1. We know m, which is our slope 4. And we know x, which is 8. Okay, so to get our equation, we're going to simplify and solve for y. Okay? So let's go ahead and do what's in the parentheses first. We're going to distribute that 4. So that's going to give us 4x, 4 times the x, and the 4 times the negative 8. It's going to give us 4x minus 32. All right, then what I want to do is just move the minus 1 to their side by adding 1 on both sides. And that's going to give me y equals 4x minus 32 plus 1. When I simplify it, I get y is equal to 4x minus 31. And I'm done. This equation here, y equals 4x minus 31, is parallel to the given equation. Okay, so two lines that have the same slope but different y-intercepts, um, these are considered parallel lines. All right, let's look at the second part of this. They also want us to find the perpendicular equation to this given line. So what I like to think is I need to find its opposite slope of 4, right? So in this given slope, 4, if I'm looking at it on opposites in all aspects, opposite to a positive number is a negative number. And I can think of this as a fraction, 4 over 1. The opposite of this fraction is called the reciprocal. So I can take the reciprocal of 4 over 1, and that's 1 over 4. Hence, my perpendicular slope is going to be this, m equals negative 1 over 4. Now that I have the perpendicular slope, I can use my point slope formula again to go and to get my equation. So we're just going to go ahead and substitute just as we did before. Substitute into our equation and go ahead and distribute our negative 1/4 on the right side. We're going to get y minus 1 is equal to negative 1/4 x plus 2. The last step is add 1 on both sides. And when I do that, I get y equals negative 1/4 x plus 3. So this is the answer. This is the equation of the line that is perpendicular to our given line. Again, because of the slopes. The slope is what determines, whether a line is parallel or perpendicular. Okay? All right. Please, any questions, put them on the chat, raise your hand. All right, let's consider this new example. Consider the following. f1 is equal to 7, f0 is equal to 8. Write the linear function of f that has the given function values. All right, so again, for this one, if we want to find an equation, a linear equation, the best one to use again is our slope-intercept form, y equals mx plus b. But again, we would need to know our slope and we need to know our y-intercept. And in these two functions here, or values, they're giving us 2 points. Here, f1 refers to that my input or my x value is 1, and when my x value is 1, my y value is 4. So this is a point here, 1, 7. This other function value here is another point. When my x value is 0, my y value is 8. So what I can do is I can use my slope formula to find the slope first. Okay, so let's go ahead and do that. This equation for slope is given by y2 minus y1, or x2 minus divided by x2 minus x1. Again, where x1 and y1 is 1 point, x2, y2 is another point. It doesn't matter which you pick to be 0.1 or 0.2, as long as you follow the order. Yes, it doesn't matter which one is 0.1 or 0.2. So in my case, just because this one is first, I'm going to pick this one as 0.1. 1.7 is my 0.1, and 0.8 is my 0.2. So substituting that, I have 8 minus 7 divided by 0 minus 1. So 8 minus 7 is 1. 0 minus 1 is negative 1. A positive divided by a negative is going to give me a negative 1. Okay, so that is my slope. So now that I have my slope, I can substitute one of these values. It doesn't matter which one. I like to pick the easiest one. Since 0 is easy to work with, I'm going to pick this point to get my y-intercept and my b value for my slope-intercept form, right? This is the equation of the slope-intercept form. Y is equal to mx plus b. Let me plug in what I have. I have the y, I have an x, and I have the m. So let's go ahead and do that. So here we have Um, um, let me see. Let me do a correction here because I put the wrong values in the wrong place here. So we have 8 equals -1, and then my x value is 0 plus b. Okay. All right. So here, -1 times 0 is 0. So 8 is equal to b. So what this is telling me that positive 8 is my y-intercept. So the equation is y equals -x plus 8. Yes? I also could have used my point slope formula to do that, but um, it works either way. I think this was the easiest way. Again, just didn't I skipped a step. I'm adding the step that I overlooked. Right? All right. Let's look at this example. Find the function values if possible. F of x is equal to 3x minus 1. All right, so the first example here, it's easy. It's telling me that when I want to find out what f of x is, is equal to when I plug in 1 for x. So let's go ahead and do that first one. This is telling me that everywhere I see x, I'm going to plug in 1. So let's do the substitution. F of 1 is equal to 3 times 1 minus 8. Let's go ahead and simplify. 3 times 1 is 3, and 3 minus 8 is a -5. So when my input value 1 for the function, my y value or my output was -5. About the second example, x plus 4, okay? Doesn't change anything. All I'm going to do is everywhere I see x, I'm going to substitute it with this equation, x plus 4. So let's go ahead and do that. We have f of x plus 4 is equal to 3 times x plus 4 minus 8. So I'm going to simplify by first distributing the 3 to those two values. So I'm going to get 3x plus 12 minus 8. So 12 minus 8 is 4. So my final answer is 3x plus 4. When my input value was x plus 4, my output value is going to be 3x plus 4. Okay. All right, how about this one? This is a little bit more complicated. So we have this given equation or function gt is equal to 5t squared minus 6t plus 4. And they want me to evaluate, if possible, g of 2. But all this is telling me that everywhere I see t now, I'm going to plug in this 2. So let's go ahead and do that. We have 2 squared minus 2 plus 4. Let's go ahead and simplify. So 2 squared is 4. A -6 times a +2 is a -12 plus 4. 5 times 4 is 20. 20 minus 12 is going to give me 8. And 8 plus 4 is going to give me 12. So G of 2, the output is going to be 12. Okay? All right, let's do a little bit more complicated. Uh-oh, we're going to have to do FOIL on this one. All right, again, we want to evaluate this function, g of t equals 5t squared minus 6t plus 4 for this input value, t minus 2. So again, everywhere I see t, I'm going to replace it with t minus 2. All right, let's go ahead and do that. Um, Here we have 5t minus 2 squared minus 6 times t minus 2 plus 4. All right, so on this first one, okay, I'm going to expand it first, okay? T minus 2 squared, that means I just have two of those guys. I have a t minus 2 times a t minus 2, okay? And to do this, I need to do FOIL, right? T needs to be multiplied with a t, needs to be multiplied with a -2. Then the second value from the first, -2 needs to multiply with a t, needs to multiply -2. So when I do that distribution, do that FOIL, okay, I get this. 5 times t squared minus 2t minus 2t plus 4. Again, I distributed the -6. -6 times t is a -6t. Negative 6 times a negative 2 is a positive 12, and then we have our constant plus 4. All right, so the next thing that I need to do is combine like terms on this one. I have a minus 2t and I have a minus 2t. That's going to give me a minus 4t. Okay, then I need to distribute the 5. So when I distribute the 5, I'm going to get 5t squared. So 5 times t squared is 5t squared. A 5 times a negative 4t is going to give me a negative 20. And a 5 times 4 is 20. So since I've distributed, I can get rid of my parentheses. I have minus 6t plus 12 plus 4. And then again, I'm going to combine my like terms. Now look, I look first at the 5t squared. Is there any other term that has a square? No. Well, then I leave that one alone. Then I have a negative 20t. Is there any values that have a t as well? Oh, yeah. I have this. This is a, I keep losing my pen. I have this is with a t, and this is also with a t, right? So, and they're both the same sign, so I'm going to add negative 20t minus 6t is going to be a negative 26t. Okay, do I have any more like terms? Well, yeah, I have. Let me see if I can change my color here. Um, uh, I'll just do underline. I have a constant plus 20, plus 12, and plus 4. So plus 20 plus 12, that's 32, and 32 plus 4 is 38. So when I combine all my like terms, sorry, 36. So when I combine my like terms, I have 5t squared minus 26t plus 36. Yes? Awesome. All right. Let's look at evaluating this function if possible. What they want me to do is subtract function gt minus g2. Okay, so first of all, they're giving me gt. gt is equal to 5t squared minus 6t plus 4, but they want me to subtract this given function with g2. So the first thing that I want to do is gt is just the original function given. Again, it's the same variable, so nothing changed. So we're left with a 5t squared minus 6t plus 4. Of course, if the t was something other than t, then we would have done the operation, and that's why we went ahead and gave you the example of the substitution, right? But we will get something different for G2, right? This means that everywhere we see t, we're going to plug in 2. So we have 5, 2 squared minus 6 times 2 plus 4. When I simplify that, okay, I get G2 is equal to 12. So I want to subtract these two things together. So I'm going to subtract 5t squared minus 6t plus 4 minus 12. So, and I put that in parentheses just so you know that if there was something else other than just one constant value, we have to distribute our sign. So it's easy here to see that we just have a minus 12. Now we need to just combine like terms. I have two constants. I have a plus 4 minus 12. Opposite signs, subtract and keep the sign of the larger number. So 12 minus 4 is 8, and that answer is negative 8. Okay? Excellent. All right, let's do some more examples here. So now what we're going to look at is what's called composite functions. And composite functions means that now we're going to add functions together, subtract functions together, multiply functions together, and divide functions together. So first, let me introduce these two functions. I have f of x, which is equal to x plus 2, and I have g of x, which is x minus 2. And the first example, A, wants me to add function f with function g. And the way we read this is that way. I want to f plus g of x means I want to add function f with function g. So what I tell my students is go ahead and write what they want. And then I just substitute and simplify my answers. So I like to think of this. This is the syntax that the computer or your book gives you, but it's really this, f of x plus g of x. And all I have to do now is substitute. My f of x was in red, my g of x is in blue. So here we have x plus 2 plus x minus 2. And then all I have to do is just combine my like terms. So we have x plus x is 2x, a plus 2 minus 2 is 0. So the answer for f plus g of x is just 2x. Okay. Same thing with this b example. F minus g of x. This what they want me to do is subtract function f with function g. So that's how I'm going to write it so I can do my substitution. F of x minus g of x Again, my f of x is red, x plus 2. My g of x is x minus 2. But again, because I have a subtraction, I have to distribute that sign. So to simplify, I'm going to distribute the negative. So negative times x is a negative x, and negative times a negative is a positive 2. Let's combine my like terms. X minus x is 0, and 2 plus 2 is 4. So the answer of f minus g of x is 4. Let's look at C. Oh, it's a multiplication. When I have two things next to each other, that means multiply. So they want me to do fg of x, meaning multiply function f with function g. So I'm going to write it what they want, and then I'll just do my substitution. They want me to have function f of x multiplied with function g. So let's just replace or substitute x plus 2 times x minus 3. On this one, I have to do FOIL. X times x is x squared. X times a minus 2 is a minus 2x. 2 times x is a positive 2x. And a plus 2 with a minus 2 is a minus 4. Let's combine my like terms. I have a minus 2x plus 2x. That should be 0 here. Okay, so let's do a little correction here. This should be 0. These cancel out. Okay, so there should not be a 2x here. So our final answer is just x squared minus 4. Okay, so let's go ahead and do the last example of the composite. This is read as f divided by g of x. What they really want me to do is just divide function f with function g. So let's go ahead and do that. Let's write what they're saying. F of x divided by g of x. So we have x plus 2 divided by x minus 2. Since I can simplify anything, that's going to be my answer. X plus 2 times x minus 2. Now let me see if I put it on here. But yes, on your homework for this last part, the f divided by g of x, they asked you an additional question. They ask you, what is the domain of f of g? And the reason why they do that is because this function here has a restriction. We have a fraction, right? And for fractions, we never want the denominator to ever be 0. So we need to check. Well, our answer here that we have is there a chance for our denominator to be 0? And if we don't see it, we can just do it algebraically. We can set x minus 2 equal to 0 and solve for x. And when we do that, x minus 2 is equal to 0. We see that if x is equal to 2, we will have a 0 on the bottom. You can put it on here. 2 minus 2 is 0. Hence, this is a restriction. We cannot have that 0 underneath there. So when we answer this, we're going to answer our domain in interval notation. Okay, so the interval notation for all real numbers except for 2 is given by this. Parentheses, negative infinity, comma, 2, parentheses. Now, parentheses means that I'm not including the number. And please keep in mind, always put parentheses to your infinity symbol because infinity symbol is not a number, right? Infinity just goes on forever to the left or forever to the right. So that syntax will always have a parentheses. Now, 2, I can stop at 2, but I don't want to use 2. And I'm indicating that by a parentheses. Now, if I can use a value in interval notation, it's a bracket. But for this, I don't want to use it too, so it's parentheses. So this is the left values. These are all the values to the left of 2. So the symbol that we have additional values or and is given by this like U, big U here. It's called a union or and, that we have more values that are being restricted that we can use. We can't use 2, but we can use all of the numbers after 2. And we write that by saying to positive infinity. Okay, so all of the answers when you're asking the exam for the domain, make sure you answer that in interval notation. All right, let's look at this example. Let's just do a multiplication. That way we can also practice our domain. So we have function f of x is equal to x plus 3. We have function g of x is equal to x squared minus 2. And what we want to do is we want to multiply function f with function g. So again, I'm just going to write them out. So we have here f of x times g of x. So when I do this, when I do FOIL, okay, I'm going to multiply x times the x squared, x times the minus 2. Then I'm going to multiply the 3 times the x squared and the 3 times the minus 2. combine my like terms, and I'm going to get this. X cubed minus 3x squared minus 2x minus 6. Okay? All right, so I was getting ahead of myself. This one, there's no restrictions, right? Because there's not a fraction. So again, my domain, if they were to ask me what is the domain of this, in interval notation is from negative infinity to positive infinity. Yes? All right. Let's look at now, well, we saw combination functions. Now let's look at the composite function. So when we see this little f composed of g, this is how we're going to read it. What this means is that we're going to have a function f, and instead of putting a value, we're going to put in another function, right? So this is what this means. So we have this function f of x is equal to x plus 4, g of x is equal to x minus 9. So let's do a first. Since we had f first, the way I like to write it is like this. Function f is composed of g. That means that for the function f, I'm going to plug in another function, which is g of x. So the first thing that I do when solving this is I'm going to write function f. Function f is x plus 4, right? So and I would write f of x plus 4. And then all I have to do is everywhere I see x, I'm going to plug in x minus 9. I'm going to evaluate this. Okay, so let's go ahead and do this. So we have f of x is x plus 4. So at x, I'm going to plug in x minus 9. So here we have x here. And I skipped some steps, but I have x minus 9 plus 4. So now let's go ahead and simplify. I'm just going to combine like terms. So I only have two constants. It's just going to be my minus 9 plus 4. It's going to give me my minus 5. So the composite function of f composed of g is x minus 5. Let's look at b. They flip the order. That means my main function is g, and I'm going to evaluate g by plugging in function f, which I'm going to plug in x plus 4. So I like to rewrite it like this. G composed of f is the same thing as g, function g, and to function g, I'm going to plug in function f of x. Okay, so and I'm evaluating f of x, which is x plus 4. Again, g is x minus 9. Everywhere I see x, I'm going to plug in x plus 4. So we have x plus 4 minus 9. Let's go ahead and simplify, and we have x minus 9. Now, I also want to give you a warning. This example that we chose, f.g and g.f gave us the same value, but this doesn't always happen. This one just was by chance that we have the same value, but this doesn't happen all the time, or it hardly ever happens. It just happened this time. But so don't think that if you have f of g, you have g of f the same. Don't do that mistake. Okay, value. This is just a once in a lifetime, you can say. All right. Now I get a lot of questions on this one. G composed of g. This one's easy, guys. This one is just everywhere I see g, I'm gonna plug in the same function. So I like to rewrite it by doing it like this. My main function is g, and I'm gonna plug in function g. Okay, so g is x minus 9, and everywhere I see x, I'm gonna plug in x minus 9. So we have x minus 9 minus 9, and then combine my like terms, I get x minus 18. Yes? All right, so these were, I started off with my combination functions, and these are my composite functions. All right, let me see. Let me go ahead and I'll skip through this one just because I have 10 more minutes and I want to get through all of the examples to get you ready for your exam. Again, these sessions are recorded, so they're uploaded to our EPC YouTube channel, so you can go back and review them, okay? So this is just an example. More examples of composites. So let's look at this one. Does a function have an inverse? So we saw that for a function to be a function, of a graph, we did a vertical line test, right? And we said that if every x value corresponded to one y value, that was a function. Well, an inverse is the opposite of a function, right? That's what the word inverse means, opposite. So for a function to be an inverse, we swap everything. A function was every x value had to have its own y value. Now an inverse, every y value has to have its own x value. So what's opposite of a vertical line? Horizontal line. So we can use a horizontal line test to test if this graph is an inverse function. And again, if we draw an imaginary horizontal line, we'll see that every y value only corresponds to one x value. So hence, this graph is an inverse. Okay. All right. So this is what I just talked about, our horizontal line test. All right. So let's look at this one. Determine whether a function has an inverse. So I know that this is a linear function, so I know it's going to have an inverse. Now, if I want to find the inverse, the way I find the inverse is do this. I do it through steps. The first thing I do is I replace the function by creating it as an equation. Remember, f of x was replacing the y, so I'm going to make it back into an equation. So I have y is equal to 5x plus 4. So the next thing that I'm going to do is I'm going to interchange, or I'm going to swap the x and y values. I'm going to make the y's values x and the x values y's. So I'll do that, and I have x is equal to 5y plus 4. Now all I have to do is solve for y, and I'm going to subtract 4 on both sides, divide by 5 on both sides, and I'm going to get y equals 1 over 5x minus 4/5. Okay, but I have to change that y back to indicate that this is an inverse, and the syntax or the notation for inverse is given by f to a superscript of -1. Okay, this means inverse. Don't forget to do that. So again, if you can see, these are opposites of each other. First, the 5 was being multiplied with the x. Now the 5 is being divided to the x. And then we have a y-intercept, yes? So this is what inverse functions are and how to calculate. Uy, actually, I finished. Does anybody have any questions? Ms. Chuka, would you like to add anything?
Hi, Mr. Carizales. Thank you.
Hello.
Just to in case you want a copy of this PowerPoint, on the right side, about right here, you should see a symbol that looks like this, and it has a box with an arrow. If you click on that box, it's gonna allow you to download the PowerPoint or the PDF file that we're using. And we do have tutors available. We have some time here if you have questions. Most of you are going to take your test maybe by this Sunday. Some of you might have it due on Sunday if it's an online class, or some of you are going to take it next week. So whenever you take it, we just want to wish you the best, and feel free to stay here and ask us any questions you might have. And starting next week, we'll go into chapter 2, and then we'll start splitting up. So we'll have you'll all come in here, but then we'll split you up into 13, 14, 13, 24, so that we can focus on each of those classes. But I guess that's it. If you have questions, we'll be here.
So thank you all for joining us again. Please stick around. We have excellent tutors that if you have additional questions, feel free to stick around. Thank you all for joining us this Friday. Good luck.
Thank you, everyone. We hope you have a wonderful